All right, in this video, we're going to be looking at how to find unit circle trig values. What do I mean by this? I mean, if I ask you, what's the sine of 7 pi over 6? Or what's the cotangent of 330 degrees? How can you answer these questions quickly without a calculator? So that's what we're going to look at right now. First, we have to remember SOHCAHTOA. SOHCAHTOA. Got to be able to spell that the right way. SOHCAHTOA, the sine is the opposite over the hypotenuse. Next I have CA. The cosine is the adjacent over the hypotenuse. And then TOA, the O and the A, are the opposite over the adjacent. So these three trig functions we should have learned in geometry. We also have their reciprocal functions. So if we flip them, if we flip the sine, we have the cosecant. The cosecant, therefore, is the hypotenuse over the opposite. If we flipped the cosine, we have the secant. And the secant is therefore the hypotenuse over the adjacent. And if we flip the tangent, we have the cotangent. The cotangent is the adjacent over the opposite. So that's the trig part of finding unit circle trig values. Now we need to worry about the unit circle. Well, what's the unit circle? The unit circle is a circle of radius 1 with the center at the origin of a rectangular coordinate system. Looks like I forgot the 1 in there. Very important, that 1. That's what the word unit means. It's not just any circle, it's a circle whose radius is 1. That means if I look at the coordinate of this point right here where the positive x-axis intersects the unit circle, its coordinates are going to be over 1 up 0. I could also come up to where I meet the positive y-axis. Those coordinates will be 0, 1. Over here on the left, I've now gone negative 1, 0. And down here where my circle meets the negative y-axis, my x value is 0 and my y value is negative 1. So that's all the unit circle means, is a circle of radius 1 with the center at the origin of a rectangular coordinate system. But where are the triangles? What we're going to do to get triangles so we can have trig functions is we're going to put an angle in standard position right here at the center of our circle. And if we do that, we will have an x value of our circle as the adjacent side of our triangle. We'll have the y value of a coordinate on our circle as the height of our triangle, or the opposite side from our angle theta here in our circle. And our hypotenuse, well, the hypotenuse is the radius of the circle, which we said was very important, a unit circle with radius 1, so our hypotenuse is always going to be 1 when we put a triangle in our circle like this. Now if we go back to our trig functions that we just had a second ago, the sine is the opposite over the hypotenuse, which means y over 1 if we're in the unit circle, and the sine is just the y value of the unit circle. The cosine is the adjacent, or the x value, over the hypotenuse, which was 1. So the cosine is just the x value of any coordinate on the unit circle. The tangent is the opposite over the adjacent, which makes it the y over x, or if you prefer, you can also think of it as the sine over the cosine. Any of those things will work. I need to know 3 special right triangles. I need to know the 30-degree special right triangle. That's a 30, 60, 90 triangle, which is also pi over 6. So I should always recognize that 30 degrees is equal to pi over 6, and those will all create the same family of rectangles. In this triangle, the short side will be 1/2. The medium side is the square root of 3 over 2, and the has to be 1 because I've made my hypotenuse the radius of my unit circle. All right, I also can have a 45, 45, 90 triangle. 45 degrees is 1/4 of a pi. If I put my 45-degree angle in my unit circle, again, my radius has to be 1, so my adjacent and my opposite are both the square root of 2 over 2. I should have this triangle memorized as well. My third angle would be a 60-degree special angle, or pi over 3 in radians. This triangle is really just a reorienting of my previous triangle. So now it's a 30, 60, 90 triangle with the short side on the x-axis, the medium side going up, and again, my radius is the hypotenuse, which is 1 in the unit circle. It's essential that you have these 3 triangles memorized. If you don't, pause the video while you write them down. I wrote each of these triangles down so you can pause them if you need to write them. So now let's calculate a trig value. At the beginning, I said you should be able to find the sine of 7 pi over 6. So what should I do when I see this problem? First of all, I should think pi over 6 is my 30-degree reference angle, so I know I'm going to have a 30, 60, 90 triangle. I should also know, where is 7, 6 going to land? 7, 6 is 1 1/6 of a pi. So if I'm drawing my angle in standard position, I need to go 1 and an additional 1/6 of a pi. That means that I'm right here with a 30-degree reference angle. Now I know that sine is my opposite over my hypotenuse. This is the short side, the opposite of my triangle, so it's 1/2. It's also going down, so it's a -1/2. The hypotenuse is just 1 in this triangle. I'm not going to worry about the x value because I don't need that for sine. The sine of 7 pi over 6 is -1/2 because it's the opposite over the hypotenuse. What if I asked you to find the cotangent of 330? Well, in standard position, 330 is going to be 30 degrees short of 360. For the cotangent, I need to flip the tangent. So I'm going to need to know both the opposite and the adjacent. The short side of the 30, 60, 90 triangle is 1/2. That's going downward, so it's negative. The medium side, or the adjacent side of my 30, 60, 90 triangle, is the square root of 3 over 2. That's positive because it's going to the right. I know from the TOA part of SOHCAHTOA that the tangent is the opposite over the adjacent. Since the cotangent is the reciprocal, the cotangent is the adjacent over the opposite. So I was looking for the cotangent of 330 degrees. Looking at my triangle, the adjacent side was the square root of 3 over 2, and the opposite side was -1/2. Now I just need to simplify this fraction. I can reduce out my 2's, and I'll have the square root of 3 over -1, or simply negative the square root of 3. Let's do one that's not a 30, 60, 90 triangle. What if I asked you to find the tangent of 5 pi over 4? Well, when I look at this one and I see fourths, I should recognize that pi over 4 is 45 degrees. So I know I'm going to have a 45-degree reference angle when I make this triangle. I also know that 5 pi over 4 is 1 1/4 of a pi. So 1 pi is half of a circle, and an additional fourth would put me right here with my 45-degree reference angle. In a 45-degree triangle, my sides were square root of 2 over 2 and square root of 2 over 2. Since my adjacent is going to the left, it's a negative square root of 2 over 2, and my opposite is going down, it's also a negative square root of 2 over 2. Since the tangent is the opposite over the adjacent, negative square root of 2 over negative square root of 2 over 2 reduces to +1. How about a cosine? What if we were to find the cosine of 3 pi over 4? Again, I should realize that pi over 4 is a 45-degree reference angle. An entire pi would take me all the way to the left side of my unit circle. So 3/4 of a pi means I'm 1/4 short, and my reference angle is 45 degrees here. The cosine needs the adjacent side of my unit circle. The adjacent side of my 45, 45, 90 triangle is the square root of 2 over 2. It's to the left, so it's negative. Cosine also requires the hypotenuse, but the hypotenuse in my unit circle is just 1, so I don't really need to worry about it when I'm finding the cosine. The cosine is the adjacent, or negative square root of 2 over 2, over the hypotenuse, which was 1, so again, I didn't have to worry about it. My final answer is just negative square root of 2 over 2. How about the cosecant of 5 pi over 3? Well, I should recognize that pi over 3 is 60 degrees, so I know that this is going to have a 60-degree reference angle. I also realize that 5 pi over 3 is 1 2/3 of a pi. That means when I'm drawing my angle in standard position that I'm going to be 1/3 of a pi short of going all the way around my unit circle, and this will be my 60-degree reference angle in here. So for cosecant, I need the reciprocal of the sine. So I'm going to need to know the opposite of this triangle. It's the long side of the triangle, which was the square root of 3 over 2. It's going down, so it's negative. The hypotenuse, since I'm in my unit circle, is just 1. So if I ask to find the sine of 5 pi over 3, that would just be negative square root of 3 over 2. What I'm looking for is the cosecant of 5 pi over 3, which is going to flip my sign and make it negative 2 over the square root of 3. I can't leave the square root of 3 in the bottom of a fraction, so I'm going to multiply by the square root of 3 over the square root of 3 to rationalize, and my answer is negative 2 square roots of 3 over 3. What if I had to find a trig value for the cosine of pi? Well, pi is a quadrantal angle. I can't draw reference triangles for my quadrantal angles because there's no way I can make an acute angle that's going to land right here on pi. I wouldn't be able to go up at all. My height would be 0 for my triangle. So for this, I'm going to need to go by the coordinate on the unit circle. The coordinate on the unit circle was negative 1, 0. Remember, the coordinates of the unit circle tell me the cosine and the sine of the related angle. They also, if I prefer, tell me the adjacent and the opposite. To find the cosine of pi, my answer therefore is just negative 1. By the way, if I wanted the sine of pi, the sine of pi would be the y value from the unit circle, which is 0. How about the secant? The secant flips over the cosine. If I flip over the negative 1 I had up here, it will still be equal to negative 1. How about if I flip over the sine? When I flip over the sine, that gives me the cosecant. Whoops, that should be pi in there. This one should have been pi too, sorry. If I'm looking for the cosecant of pi, I need to flip over the sine of pi. When I flip that over, the 0 becomes on the bottom. I'm not allowed to divide by 0 in a fraction. So my answer to what's the cosecant of pi, this is undefined. It does not exist. You can either write the whole word or you could write UND or DNE. How about the rest of them? So we finish these out. I could also find the tangent. The tangent of pi is the opposite over the adjacent, or the y over the x, or the sine over the cosine, however you want to think about it. 0 divided by negative 1 reduces to 0. If the tangent is 0, when I go to do the cotangent and take its reciprocal, that means the cotangent is also going to be undefined. At each of the quadrantal angles, two of our trig functions are going to be undefined because with either the opposite or the adjacent being 0 at each of our quadrantal locations, there's going to be two things that won't work. So in summary, what do we need to know to find the unit circle trig value? We need to know what SOHCAHTOA means. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. This also means that the sine is the y value on the unit circle. The cosine is the x value on the unit circle. The tangent is y over x. That means the cosecant flips y, the secant flips x, and the cotangent flips to x over y. We need to know our three special right triangles. We need to know that 30 degrees is a sixth of a pi, and our special right triangle for 30 degrees has a short side of a half and a medium side of square root of 3 over 2. The hypotenuse is always 1 in our unit circle. The 45 degree angle is equal to pi over 4 in radians. A 45 degree reference angle will have both an opposite and an adjacent of square root of 2 over 2, and the hypotenuse again has to be 1. 60 degrees is pi over 3 radians. The 60 degree angle looks just like the 30, 60, 90 triangle, except for now my short side is on the bottom and the medium side is across from the square root of from the 60, making that square root of 3 over 2. And what if it's quadrantal, like pi, or a multiple of pi over 2? Well, in that case, just use the coordinates of the circle, which are all going to be something like 0, 1, or 1, 0, or negative 1, 0. And remember that the x value is the cosine, and the y value is the sine. Using this method, you can find any trig function for any of our special angles.